precious metals, more than just shine. Gold, silver, platinum. These metals have been symbols of wealth and power throughout history. These metals have captivated humans for centuries. Their beauty is undeniable, their value is undeniable. From ancient civilizations to modern times, they have been cherished and sought after. But have you ever stopped to think about where they come from? The journey of these metals is as fascinating as their final form. How do we get these precious metals from the earth to your finger? The process is intricate and labor-intensive. It's a dirty job, no doubt about it. Miners often work in harsh and dangerous conditions to extract these valuable resources. Miners, engineers, and refinery workers work tirelessly to bring these metals to light. Their dedication and expertise are crucial in every step of the process. It's a fascinating process that involves heavy machinery, complex chemistry, and a whole lot of hard work. Each stage requires precision and skill. In this essay, we're going to dig deep into the world of precious metal production. We'll explore the challenges and triumphs faced by those in the industry. We'll follow the journey of these metals from the mines to the refineries. Each step is a testament to human ingenuity and perseverance. We'll uncover the secrets behind their extraction and refinement. The transformation from raw ore to polished metal is nothing short of magical, so buckle up and get ready to get your hands dirty. This journey is not for the faint-hearted, but promises to be enlightening. We're about to unearth the fascinating story of how gold, silver, and platinum are produced. From the depths of the earth to the pinnacle of craftsmanship, join us on this incredible adventure. Unearthing treasure, mining for gold, silver, and platinum. First things first, we got to get these metals out of the ground. That's where mining comes in. There are two main types of mining: surface mining and underground mining. Surface mining is used when the deposits are close to the surface. Think big open pit mines. Underground mining is used for deposits deeper underground. This involves digging tunnels and shafts to reach the ore. Gold is often found in veins running through rock. Silver is similar, often found alongside gold or other metals. Platinum, on the other hand, is usually found in layered deposits called reefs. No matter the method, mining is a tough job. It's dangerous and demanding, but it's the essential first step in getting these precious metals into our hands. Gold extraction from rock to riches. Once the gold ore is mined, it's time to separate the gold from the rest of the rock. This is where things start to get technical. One common method is called cyanidation. In this process, the ore is crushed and ground into a fine powder. Then it's mixed with a cyanide solution. The cyanide dissolves the gold, separating it from the rock. The gold cyanide solution is then treated to recover the gold. This can be done using techniques like activated carbon adsorption or electrowinning. The end result? Pure gold. Silver extraction, unveiling the moon metal. Silver extraction is often linked to gold extraction. Remember, these metals are often found together, so the same process is used to extract gold can also be used to extract silver. However, there are other methods specific to silver. One such method is called amalgamation. In this process, the crushed silver ore is mixed with mercury. The mercury forms an amalgam with the silver, separating it from the ore. The amalgam is then heated, vaporizing the mercury and leaving behind the silver. It's an effective method, but it's important to handle mercury with extreme care due to its toxicity. Section 5, Platinum extraction, isolating the noble metal. Platinum, one of the rarest and most valuable metals, requires a meticulous extraction process. Platinum extraction is a bit more complex than gold or silver. This complexity arises from its unique properties and the way it is found in nature. That's because platinum is often found alongside other metals like palladium and rhodium. These metals are part of the platinum group metals, PGMs, which share similar chemical characteristics. These metals are chemically similar, making them difficult to separate. The challenge lies in their similar densities and chemical behaviors. The first step is similar to the other metals: crush and grind the ore. This reduces the ore to a fine powder, increasing the surface area for the next steps. Then a process called froth flotation is often used to concentrate the platinum. This method is effective in separating the valuable minerals from the waste rock. This involves bubbling air through a mixture of the ore and chemicals. The chemicals used are designed to make the platinum particles hydrophobic or water repellent. The platinum attaches to the air bubbles and floats to the top where it can be collected. This froth is rich in platinum and other PGMs. After flotation, the concentrate undergoes a series of chemical processes to separate the platinum from the other metals. These processes are designed to exploit the slight differences in chemical reactivity. This typically involves dissolving the metals and then selectively precipitating them out. Each metal is precipitated at a different stage, allowing for their separation. It's a complex and precise process. The expertise required to perform these steps ensures that the final product is pure platinum, ready for use in various high-tech applications. Section 6. Crushing and grinding, breaking down the barriers. We've mentioned crushing and grinding a few times now. Let's take a closer look at this essential step. The goal here is to break down the ore into smaller and smaller pieces. This increases the surface area, making it easier to extract the metals in later stages. Crushing is the first stage, using massive machines called jaw crushers or gyratory crushers. These behemoths can crush rocks as big as cars. The crushed ore then goes to grinding mills, where it's ground into a fine powder. Think of it like using a giant mortar and pestle. Section 7. Separation techniques, concentrating the value. Once the ore is crushed and ground, it's time to separate the valuable minerals from the waste rock. This is where things get really interesting. There are a number of techniques used, and the choice depends on the specific characteristics of the ore. We already mentioned froth flotation, which is commonly used for platinum. Another common method is gravity separation. This technique relies on the differences in density between the minerals. The crushed ore is fed into a device called a shaking table or a spiral concentrator. The heavier, valuable minerals sink to the bottom while the lighter waste rock is washed away. These separation techniques help to concentrate the valuable minerals, making the extraction process more efficient. Section 8. The power of chemicals, leaching and adsorption. Now that we've concentrated the valuable minerals, it's time to extract the metals themselves. This often involves using chemicals, and two common processes are leaching and adsorption. Leaching involves dissolving the metals out of the ore using a liquid solvent. We already saw this in action with gold cyanidation. The solvent is carefully chosen to dissolve the target metal while leaving the other minerals behind. Adsorption, on the other hand, involves using a solid material to selectively adsorb the metal ions from a solution. Remember activated carbon adsorption from gold extraction? That's a prime example. The activated carbon acts like a sponge, soaking up the gold ions from the solution. Section 9. Refining fire. Purifying the metals. The metals extracted from the ore are often not pure enough for commercial use. They may still contain impurities from the ore or from the extraction process itself. That's where refining comes in. Refining is the process of purifying the metals to achieve a desired level of purity. One common method is electrorefining. This involves using an electrolytic cell to selectively plate the pure metal onto an electrode. Remember electrowinning from gold extraction? It's the same principle. Another common method is smelting. This involves heating the impure metal to its melting point and then selectively oxidizing the impurities. The impurities are then removed as gases or slag, leaving behind the purified metal. Section 10. Shaping the future applications of gold, silver, and platinum. These metals have been treasured for centuries, not just for their beauty, but for their incredible utility in modern technology and industry. After all that hard work, we finally have pure gold, silver, and platinum. These metals are not just symbols of wealth, they are essential materials that drive innovation and progress. But what do we do with these precious metals? Their applications are vast and varied, touching almost every aspect of our daily lives. Turns out they have a wide range of applications across numerous industries. From the technology that powers our devices to the machinery that builds our world, these metals are indispensable. Gold, with its resistance to corrosion and its excellent electrical conductivity, is a vital component in electronics. It's found in connectors, switches, and even the microchips that run our computers and smartphones. It's also used in dentistry, jewelry, and even as an investment. Gold's malleability makes it perfect for intricate designs in jewelry, while its biocompatibility makes it ideal for dental work. Silver, with its similar properties to gold, is also used in electronics and jewelry. Its superior conductivity makes it essential in high-performance electronics, and its luster makes it a favorite in fine jewelry. But it's also a powerful antimicrobial agent, finding applications in medicine and water purification. Silver is used in medical instruments, wound dressings, and even in coatings for water filters to ensure clean, safe water. Platinum, the densest of the three, is highly valued for its catalytic properties. This makes it crucial in chemical reactions, especially in the automotive industry. It's used in catalytic converters for vehicles, reducing harmful emissions. Platinum helps convert toxic gases from car exhausts into less harmful substances, playing a key role in environmental protection. It's also used in jewelry, dentistry, and even in cancer treatment. Platinum's durability and resistance to tarnish make it ideal for fine jewelry, while its stability and biocompatibility are crucial in medical applications, including chemotherapy drugs. Section 11. Conclusion: the enduring value of precious metals. From deep within the earth to the devices we use every day, the journey of gold, silver, and platinum is a testament to human ingenuity and perseverance. The extraction and refinement processes are complex, involving a delicate dance of heavy machinery, precise chemistry, and skilled labor. These precious metals, once just glittering treasures, now play vital roles in our modern world. They power our electronics, adorn our bodies, and even contribute to our health and well-being. So, the next time you hold a piece of gold, silver, or platinum, take a moment to appreciate the journey it took to get there. It's a journey that reflects